Data structures using C++. Part 7. Array operations. Traversing of array. Traversing means to access all the elements of the array starting from first to the last one by one. The algorithm is: Step 1, initialize the counter, set I equals lower. Step 2, repeat for I equals lower to upper. Display AI. End of loop. Step 3, end. Insertion in one-dimensional array. Insertion of a new element in an array can be done in two ways. A. Insertion at the end of array. B. Insertion at required position. Inserting an element at the end of an array can be easily done, but the memory space allocated must be large enough to accommodate the new element. Let we have an array. We want to insert 85 at the end. Then the array is, this is insertion at the end of array. 8. Then insertion at required position. For inserting the element at required position, elements must be moved downwards to new location, to accommodate the new element and keep the order of the elements. Look at this array. A0, A1, A2, A3, A4. Suppose we want to insert 20 in array at location with index 1. Going to insert 20. It means the elements 56 onwards must be shifted downwards as shown. Insertion and shifting. Now, look at the array. A0, A1, A2, A3, A4, A5. The algorithm is: Step 1, set I equals len. Step 2, repeat I equals len down to POS, shift the elements down by one position, set AI plus 1 equals AI. End of loop. Step 3, insert the element at required position. Set A POS equals number. Step 4, set len equals len plus 1. Step 5, display the new list of arrays. Step 6, end. Deleting an element from one-dimensional array. Deleting an element at the end of an array presents no difficulties, but deleting elements somewhere in the middle of the array would require to shift all elements to fill the space emptied by the deletion of the element. Deleting from the end. Look at the array. A0, A1, A2, A3, A4. Deleting from the end, we want to delete element from end position. A0, A1, A2, A3, A4. Deleted 65. Then, deleting from a required position. A0, A1, A2, A3, A4. We want to delete 78. We want to delete 78, that is from another position. Deleted 78. Shifting all elements to the space emptied. A shifted. A0, A1, A2, A3, A4. The algorithm is: Step 1, set item equals A POS. Step 2, repeat for J equals POS to N1, shifting all elements one position upwards. Set AJ equals AJ plus 1. End of loop. Step 3, reset N equals N1, because after deletion size is reduced. Step 4, display the new elements. Step 5, end. Merging two arrays. Merging means combining elements of two arrays to form a new array. If you want the resultant array to be sorted, use the technique sorting while merging. Look array 1 and array 2. Here you can see the merged array C. A0, A1, A2, A3, A4, B0, B1, B2, B3, B4, C0, C1, C2, C3, C4, C5, C6, C7, C8, C9. Merged array C. Algorithm for merging two arrays. Step 1, create 3 arrays. Step 2, enter the elements in ascending order in 2 arrays. Step 3, initialize m and n to 0. Step 4, check if array 1m equals array 2n. Assign elements of array 1 to array 3. Set C equals C plus 1. Else. Assign elements of array 2 to array 3. Set C equals C plus 1. Step 5, assign remaining elements of array 1 and array 2 to array 3. Step 6, display the elements of array 3. Step 7, end. Thank you. Like, share, subscribe.